Hello all, I'm Dr. Vishnu. Would like to give a small introduction to biochips. A biochip is a collection of miniatured microarrays arranged on a sturdy substrate, enabling simultaneous execution of multiple experiments to achieve a high throughput in a shorter duration. Generally, these microarrays, miniature microarrays means nothing but small laboratories or mini laboratories, which are biosensors. These biosensors, a group of biosensors form a biochip which perform simultaneously multiple experiments or multiple tasks in a short duration. So this biochip contains millions of sensor elements or biosensors. A biochip can be considered as a micro reactor or mini laboratory, micro laboratory that can detect a particular unlike like an enzyme, protein, DNA, biological molecule or antibody. So the main function of this biochip is to perform hundreds of biological reactions in a few seconds like decoding genes. When it comes to the components of biochip, the size of the biochip is very small. So its size is not greater than that of a fingernail. You can see almost it is equal to the size of this rice grain. About the components of the biochips, it can be divided into two parts. One main part is transponder, which is the actual implant of the biochip, and another one is a reader. So this is a transponder which consists of the microarrays, that is a group of biosensors, and the signal processing unit, that is nothing but the reader, which receives and signals to the transponder as well as the output device like LCD. Let us discuss in detail about the transponder. Transponder is the actual biochip implant. This is the main part of the biochip. These are of two types. We have active transponders, passive transponders. So passive transponders mean they don't have any energy source. So there is no battery or energy of its own, whereas active transponders has a power source. So because the passive biochip contains no battery or nothing to wear out, it has a very long life up to 99 years, and there is no maintenance. Now, transponder consists of four parts. The first one is a computer microchip, tuning capacitor, antenna coil, and a glass capsule. So one can check here. So this is a microchip which is connected to a tuning capacitor here, and this tuning capacitor is connected to a antenna coil, and the whole system or the setup is arranged in a glass tube, soda lime glass. So such tube, it is more biocompatible. Now this is the block diagram of this biochip. Let us see one by one. So computer microchip. This computer microchip consists of the unique identification number about 10 to 15 digits long. 10 to 15 digits long. So this unique ID number is encoded via a laser onto the surface of the microchip before assembly. It is not possible to alter the number once it is encoded. Along with this microchip, it also contains electronic circuitry which is necessary to transmit the ID number to the reader. The second part of this transponder antenna coil. So it is a simple coil of copper wire around a ferrite or iron core. So used to send and receive the signals from the scanner or reader. The capacitor stores the small electrical charge less than 1 by 1000 of a watt sent by the reader or scanner, which activates the transponder. This activation allows the transponder to send back the ID number encoded in the computer microchip. So the capacitor is tuned to the same frequency as reader because radio waves are utilized to communicate between the transponder and reader. Next, The last part of this transponder, glass capsule. So the glass capsule holds the antenna coil, capacitor and microchip, and it is made with a biocompatible material, namely soda lime gas. The last one, the reader. So reader consists of an exciter coil which creates an electromagnetic field to excite the implanted biochip. So the tuning capacitor that receives this electromagnetic field stores in the form of small electrical energy which is activating the transponder. So this reader carries a receiving coil that receives the transmitted code or ID number from Biochip and decodes the received code to display the result in the LCD display device. Now come to the advantage of this Biochip. Biochip in a few seconds can execute hundreds of biological responses. Manufacturing and operating costs are expected to be low. Rapid point care diagnostic tool for patients. Multiple tests can be performed simultaneously. Storage of more information in a much smaller space. Compared to silicon chips, biochips have reduced crosstalk and more reliable intercommunication. Biochips can help to locate persons who have gone missing. So these are the advantages of the biochip. Come to the applications. Biochips can be used for tracing of persons or animal anywhere in the world is possible, tracking bird migration cycles as well as tracking spies for national security, detecting chemical agents during biological warfare, to store and update financial, medical records, demographic data, etc. Biochips are replacing passports, cash, and medical records. They are also used for testing water and environment. Medicinal implementation of biochips as glucose detector, as oxygen sensor, as a blood pressure sensor, and also advanced applications include genome mapping and sequencing, drug discovery, environmental monitoring, disease discovery, and diagnostics. Even in the drug delivery systems, the biochips can be extensively used. This is all about the biochips introduction, a small topic. Thank you.